So today we are going to solve this LeetCode daily challenge, trapping rainwater 2. Given an m into an integer matrix height map representing the height of each unit cell in a 2D elevation map, we need to return the volume of the water that is trapped. So what we can do is, first we can take this example. Okay, so we will start, we will first define what is a safe cell and what is an unsafe cell. A safe cell is one on which if you pour water, the water won't go out of the grid. And the unsafe cell is on which if you pour water, it will go out of the grid in some way. Okay, so if AB cells are adjacent and B is unsafe and height of A is uh, less than or equal to B, height of B, then A will also become unsafe, because if we pour some water on B, B is unsafe, so that water will go to A and A will also become unsafe. Okay, I'm sorry, height of A is greater than equal to B. Like if B is unsafe and we pour some B is unsafe, it means that if we pour some water on B, the water will go out of the grid. So if height of A is bigger than B and A is also attached to B, so if we pour some water on A, it will fall on B, and B is an unsafe cell, so A will also become unsafe. Okay, so what we are going to do is we will choose some minimum height. Like for some height we are going to talk about. Suppose the height is 1. So if a cell is at the border of the grid, it will always be unsafe. If you pour water on any cell which is present on the border, the water will go out of the grid. So suppose 1 is one of those cell, like this one is unsafe, this one is also unsafe, and this one is also unsafe. Okay, and whatever whatever one which is present which is not unsafe, like the water will be trapped in that, so this one is safe. Water will always remain trapped in this. Now, is it possible that this one can also become unsafe? Yes. If this is also 1. Now see, this one is unsafe, this one is unsafe, this one is also unsafe because it is on the border, and this is also unsafe. And because this is unsafe and this one is adjacent to it and it is of equal height, so it will also become unsafe. So what we are going to do, we will choose a height and check, like if it is on the border. If it is on the border, we'll mark it unsafe. Then we will mark it unsafe, and all the heights which are equal to it and are adjacent to it, uh, those also will mark unsafe in a DFS fashion. So uh, like if this one is unsafe, it is on the border and it is also unsafe, so we'll mark this unsafe, and we will also mark all the cells adjacent to it which are of equal height also unsafe, so this will also become unsafe. And similarly, if there is some cell which is adjacent to this and is of same height, like this one, if this is also 1, then this will also be marked unsafe. So like in DFS fashion we will do this. If the cell is not on the boundary, it means it is inside the grid, so we'll check if any of the adjacent cells is unsafe. If any of the adjacent cell is unsafe, then our current cell will also become unsafe. Okay, Now why it will become unsafe? This is only true if we are traversing the heights in the sorting order. Like if we are at some current cell I and the cell adjacent to is j. Now the cell j is unsafe. So when it is possible that I will also become unsafe, if height of I is greater than height of j, then only it is possible. If height of I is less than the height of j, then it is not possible. It is not possible that I will also become unsafe. It is possible that water will flow from j into I and it could become safe. So if we traverse in the height in increasing order, so whatever is marked in our grid will be, whatever heights which are marked in our grid will be less than our current height. Okay. So first we will check on the boundary. If there is some cell, then it is unsafe, and all the cells connected to it are of equal height are also unsafe. Then we'll check if that height is present inside the grid. If it is present inside the grid, we will track we will check if any of its adjacent cell whose height is like guaranteed to be less than our current height is unsafe. If that is also unsafe, then we'll mark our current cell unsafe and all the cells of equal height connected to it, those also unsafe. Let me write the observations here. It will be clearer. So first thing we discussed is that what is safe and what is unsafe. Safe cells are those on which if you pour water, it will be trapped, and unsafe are those on which if you pour water, it will go out of the grid. If two cells A and B are connected, like they are adjacent to each other, and B is an unsafe cell, B is an unsafe cell, and height of A is greater than height of B, then A will also become unsafe because whatever water we will pour on A, it will go to B, and B is unsafe, so that water will go outside the grid. The third thing is this second point uh, like helps us to know that we should traverse the height in an sorted way, so that we will always that if we are at some point of time, if we are at some height, then all the heights which are marked inside the grid unsafe are less than the current height. So we can always check this condition at that point. The third thing is which we derive from the second one, that traverse the height in sorted manner in ascending order. After this we can say, like, for current height h we are talking about, uh, if it is on the boundary, mark it unsafe, and all the cells of same height also unsafe. For current height, if that height is not in the boundary, if it is inside the grid, if it is inside the grid, then check if adjacent cell is unsafe or not. If adjacent cell is unsafe, then mark cell with height h also unsafe, and all the cells connected to it also unsafe, all the cells of same height. Okay, And finally, when you do this, currently the grid which we obtained uh, will have some cells of high touch which are unsafe and some cells of high touch which are safe. So those safe cells we could fill water in them. So fill the safe cells of high touch with 1 unit water. That is, your answer will become equal to 1, and your height map ij will also become equal to 1. Now we can say that height 1 is converted into height 2 after filling water. Okay, so these things we can do. Like we can convert that 1 unit height into 2 units after filling the water. But this is only applicable for the safe cells. Okay, so this is the basic observation which we can see in this problem. So now we'll code the solution. First we will so first we can write this. We can have a vector for the directions, like we want to go to adjacent cells for that. So this vector is, so we can use this vector to go to adjacent cells. Also we can write the DFS right now only. It will have something like we can pass the, like it will have some more arguments, and yeah. So first we will calculate the number of rows in the height map and number of columns, and this is our answer, and we'll return the answer as well. After doing this, what we can do is we can define a vector safe of n size, and currently it is true. Currently we are saying that all the cells are safe, and through the algorithm we will mark the unsafe cells. So here we could have DFS, we could have this safe, and we could also have this vector height map, something like this. We can also have a map for traversing the heights in sorted order. We can have this map. This will store the positions for a particular height. So I'm calling it points. Now we will traverse the map first. And we'll update the points array. Now we will traverse these heights. This height and the vector associated with it. Then we will fetch the point from this vector, and we could get that point by p of 0 and p of 1. If it is a boundary point, If it is a boundary point, then we can mark it unsafe. Okay, and if it is a boundary point, if it is not a boundary point, then what we can do, we can find its adjacent cell and we'll get this adjacent cell, and then we need to check like if it is inside the grid. So if it is outside the grid, we can continue. But if it is inside the grid and it is not safe, this 2i and 2j is not safe, and we know that our current cell is connected to it and it is of greater height as well. So we should mark our current cell also as unsafe, and all the cells of equal height connected to it also unsafe. So x, y, safe, and height map. And we can break here as well. After doing this, we can again, like right now our grid is marked with like for height h, we have marked all the unsafe cells. Now we'll take all the safe cells. If the cell is safe, then we'll update our answer by 1. The height of that cell will also increase, so we will also update this as well. And in the points for height h plus 1, currently we are on height h, we will also update this with the new point, because these points have now become with new height. These points are updated with the new height, so they are of height h plus 1 now. And for marking the cells unsafe, we can update this DFS. We can get the height of the height map, and we can mark it safe of x, y to false. Then we will okay, here also we can mark this safe, and we'll get 2i and 2j, x plus dir 0. And if these points are inside the grid, if these points are inside the grid and these are safe points and their height is equal to the, like it's equal to h, like their heights are same actually, then we'll again run DFS because we want to make them unsafe. So yeah, think this solution should run. Okay, so this is given TLE. What we can optimize here is this thing. Like we always increase the height by 1. Now sometimes it is possible that the next height might not be present. So like there is a height 3, and after increasing it by 1 unit, the new height will become 4. But there is no other height which is of 4 units. So suppose that inside the grid, after 3 the next height was 10. So you will increase this height 3 by providing 1 unit of water again and again. So from 3 it will go to 4, then from 4 it will go to 5. So after taking 7 steps it will reach 10. So we don't want to use these 7 steps. What we want is that after 3 it directly becomes 10. So for that what we could do is we would find the next greater height. Okay, so right now we have these points, and we could binary search on this for the uh, next higher point. Suppose our height is h, so our next point should be greater than h. So I'll search for a point which is h plus 1. Now there's possibility that h plus 1 might be present, or it won't be present. Like something greater than h plus 1 is present. So this lower bound function always returns a value which is greater than or equal to the given value. So if I'm searching for h plus 1, it will, if h plus 1 is present, it will return me h plus 1. And if it is h plus 1 is not present, then the value which is just greater than h plus 1, that will be returned. So we'll calculate the new height which we will receive. So this will be the new height, and we can update the answer by new height minus h, sorry, and this will also become new height. Why I added minus h, you can think about like this, like when we go from h to h plus 1, so you are basically adding 1, that is h plus 1 minus h. So this is how we will increase the height. Okay, and now it should pass, because this points map size was increasing again and again, so we don't want to increase the points map size. It should remain constant. So thank you for watching this video. I hope you like it. Please subscribe to my channel. Also hit the bell icon to receive any future notifications. Thank you.